There are various ways in which the surface of Titan resembles Earth's surface. Both objects have a similar atmospheric pressure and an atmosphere mostly made up of nitrogen. But the most notable similarity is that Titan is the only known body with liquid lakes other than Earth. With that, it also has evidence of rain and rivers. However, one surface feature of Titan that hasn't been fully confirmed yet is the caves. The radar images of Titan from NASA's Cassini spacecraft didn't really spot any clear signs of cave entrances. Possibly they are quite small on Titan, so the low amount of detail that the radar images provide isn't enough to reveal cave entrances. Despite a lack of direct evidence of Titan's caves, there is some pretty good indirect evidence of caves existing there. One of the more convincing ones being the fact that Titan's lakes have a sea level. Although that makes sense for two of the largest lakes, such as Kraken and Ligeia, since they are both clearly connected by a visible surface channel, that is much more puzzling for a lake like Punga and Jingpo, which don't have visible surface channels connecting them to other lakes. However, what they likely then do have is underground channels, that is, caves that connect Punga and Jingpo to the rest of the lakes, including Kraken and Ligeia. The underground channels allow for a sea level to form as the channels balance out the amount of liquid that each lake has. Those underground channels that connect different lakes can be simply called caves. However, it is unknown whether they have a size that a human could fit into. It might be just a bunch of really small channels that connect these different lakes. However, the opposite might also be the case, as in they could be huge caves. There are two possibilities in terms of the material that these liquid-filled caves formed into. They either formed into the water ice layer, or the newer layer that is also filled with water ice, but also has a good portion of organic material. Because these caves are likely going to be quite icy, we also know something about them. At Titan's temperatures of -180 degrees Celsius, water acts more like rock does on Earth. So they are probably going to be relatively stable. Water ice caves on Earth, however, are probably not comparable to water ice caves on Titan, since on Earth, water ice is way more dynamic due to the temperatures. Huge water ice cave systems on Earth can appear and disappear in a matter of just decades, or even less. Water ice cave systems that are in the water are even more dynamic, making them extremely dangerous for exploration with humans. These types of water ice caves appear on icebergs, such as B-15, the largest iceberg ever recorded at 11,000 kilometers square. The mission to explore the caves at B-15 was so dangerous that the caves were collapsing and disappearing while the mission was ongoing. Besides the stability that the water ice caves of Titan might have due to the hardness of the water ice, there is another thing that can be concluded about them. During times when there isn't much going on at the poles of Titan, when there isn't any rain, there likely are parts of the cave systems that are still probably turbulent, as in there is plenty of current going in some direction. The reason as to why that might occur could be due to the difference in local temperatures over different lakes producing a different level of evaporation, and with that a change in a liquid level, which is then possibly reflected in the caves becoming turbulent due to the liquid level being equalized between different lakes. However, even if that evaporation is not sufficient to indirectly create water currents within caves, methane rain quite likely does that. That is because over different lakes, a different quantity of methane is going to rain down occasionally, creating an uneven elevation level of liquid over different lakes, which then produces a current within the caves as the liquid is being equalized. If there is some fine organic sediment in the caves, then it is quite possibly disturbed during those times, enough such that the visibility drops dramatically. Still, this is very much just speculation, as not much is known about the visibility in Titan's lakes, let alone in liquid methane caves. Next, let's look at sea caves. Now, the previously mentioned type of cave, which is underground and filled with liquid, could also be considered to be somewhat of a sea cave. However, typically something else is meant by the term sea cave. On Earth, sea caves appear along coastlines where there are many cliffs. These form largely through the action of water over many years hitting weak spots in cliffs, which causes the rock to erode and eventually form a cave. Similarly, one would expect for these types of caves to also exist on Titan along coastlines in cliffs. Titan does have shoreline areas with pretty steep cliffs. However, the evidence for the existence of significant waves on Titan isn't very definitive. Based on how the shorelines of Titan's lakes look like, they do indicate that they formed as a result of waves. So if that is true, then we should expect plenty of sea caves to exist on Titan. Still, a significant amount of wave activity wasn't confirmed directly. However, one place which is likely to have quite a bit of movement, and with that waves, are Titan's rivers. The constant movement of liquid there could potentially create caves through erosion along the bay of the river. Speaking of rivers, it would be interesting to know as to whether or not some of Titan's caves also possess methane rivers. On Earth, cave rivers definitely do exist, along with cave lakes. For cave lakes, they very likely do exist on Titan, as it's very likely that the methane rain is accumulated enough in some caves to form a lake. The most common type of cave on Earth is the solutional cave. They form through the action of acids in water, dissolving rock slowly over time. On Titan, there obviously isn't any liquid water on the surface due to the extremely low temperature, so the exact same process of how solutional caves form on Earth isn't there on Titan. However, there is some evidence that this is similar to how lakes and lake beds formed on Titan. Not through acids in water, but rather through the action of liquid methane and possibly something in it. Besides the major lakes of Titan, which all appear to be bundled up in one spot, there are other lakes at the North Pole of Titan. Specifically, I'm talking about the much smaller lakes that are bundled up and appear to be 100 or so meters deep and a couple of tens of kilometers wide. These depressions very likely formed as a result of methane rain and possibly other components in it dissolving and/or eroding the organic-rich surface. The rate of erosion is likely slower on Titan than on Earth. However, given enough time, they should be able to form this way. Still, it should be noted that even these so-called small lakes are still tens of kilometers wide, but their size does indeed pale in comparison to the large lakes of Titan, which are many hundreds of kilometers wide. If the action of methane rain on the surface is the way that the lake beds of Titan form, then it isn't too hard to imagine that that process also creates caves on Titan. Obviously, the poles of Titan, especially the North Pole, would be probably most densely packed with solutional caves, as the poles show the signs of having the most methane rain activity. Possibly the caves connecting different lakes are solutional caves. At lower latitudes, which are much more dry, there still should be some solutional caves, just probably not as frequently. Some especially promising spots for solutional caves at lower latitudes would be the labyrinth terrain. This type of terrain is very rich in organic matter, and it is characterized by the countless densely packed valleys going in all sorts of directions. These valleys would be good spots for methane rain to create caves. And on top of that, there might be caves in the labyrinth terrain that formed due to winds. The countless valleys also provide countless cliff areas where wind can erode the material of the labyrinth terrain and create a cave. Another place where there might be caves formed through wind are the hummocky regions, which also have plenty of cliffs. There also might be solutional caves at the hummocky region too. However, the hummocky regions have much more water ice compared to other terrain types of Titan, and given the hardness of water ice at those temperatures, we can expect for it to be not very malleable, and because of that, it's possible that the hummocky regions don't really have many caves, if any. What about lava tube types of caves? They are pretty common on Earth, and they exist in abundance on Moon and Mars. However, for Titan, we really shouldn't expect for it to have them. That is because the surface of Titan is not rocky at all. Most of it is composed of a mix of water ice and organic material in differing proportions throughout the surface. Titan has a density of 1.88 grams per centimeters cubic, which tells us that it is about 40% just water, and the entirety of that water forms the top layer of Titan, which is separated from the deeper, rocky layer. Below the organic and water ice-rich surface, there is also evidence of a liquid water ocean. So considering the way that Titan is layered, we shouldn't be expecting any lava tubes to be apparent on the surface of Titan. However, there still could be ancient volcanic vents. It's just that the volcanic vents present would be of cryovolcanic origin. Cryovolcanoes spew water instead of lava. There are several possible cryovolcanoes on Titan, one of them being Doom Mons. There could be some vents here. However, the radar images don't really showcase any visible openings. It is possible that by this point, the entrances to these cryovolcanic caves, or even the caves themselves, are entirely buried, as Titan is very geologically active. Given the characteristics of Titan, there are several lines of indirect evidence pointing towards the existence of caves, with probably the strongest piece of indirect evidence being the equal elevation of Titan's lakes, pointing towards the existence of liquid, methane-filled caves that connect many different lakes. That piece of evidence also gives us another very exciting mission proposition: a submarine that tries to find these lake caves and also tries to enter them. However, at this point, such a mission is very likely not happening anytime soon. The mission set at the equator of Titan, far away from the lakes, the Dragonfly mission, got another delay in November of 2023. So currently, the Dragonfly spacecraft is set to launch in 2028. So if it really launches then, it is going to arrive on Titan by around 2034, a decade from now. Despite the understandable disappointment that such news brings, it is also way better to take time with the spacecraft such that it is assured that it lands successfully, because if it fails, we won't be getting any surface images of Titan even a decade or more from now. So even if another delay happens, we should keep that in mind. Still, the Dragonfly mission also tells us that the rate of progress going towards exploring Titan is relatively slow. So it is safe to say that the exploration of Titan's methane-filled caves, or any of Titan's caves, is at minimum a few decades away.